Welcome to basic mathematics, and then this is predominantly for the N5 course, but if it applies to you, you may use it as well. No stress. We're going to look at limits. They are very simple. And what are they? Let's say you have a function y is equal to 1 over x. I mean, if you have your quotient in this case, the denominator cannot be equal to 0. Otherwise, it will give us it shouldn't be. It will give us an infinite value, and we can't really determine the actual value of infinite. I mean, so what do we then mean? As x tends to 0, as x tends to 0, y tends to infinity. Okay, what does that mean? All right, let's put it in limit language. Limit is the limit as x tends to 0 of 1 over x will simply mean 1 over 0. X is tending to 0, which is how we know our value will tend to infinity as well. So I don't know. Let's look at another example. Y is equal to the 10 of x. Now, let's suppose x is as you edge towards 90 degrees. What is the 10 of x? 10x tends to 10 of 90, which is infinite as well. So what does it mean? 10, the limit as our x tends to 90 of the 10 of x simply means the 10 of 90. All right, and that there will be undefined. All right, so limits is basically us looking at our graphs or our graphs and determining what they tend to do as our variable or our dependent variable, rather our independent variable tends to a certain value. What does the dependent variable tend to do in that case? So it's not really train smash. All you do is, if you are required to do a limit as x tends to a general value, any value, it simply means for a function f of x, it simply means the f of that value. I don't think it's complicated. I actually think it's easy enough. But let's look at another example. Let's say we have the limit as x tends to say 0 of something like e to the power of x minus 1 over x. Well, if I'm going to follow this rule, I'm going to say e to the power of 0 minus 1 over 0. I'm simply substituting, and this is going to say 1 minus 1 over 0, which is 0 over 0. Indeterminate, I cannot say what that is going to be. Indeterminate, what am I doing? Undetermined, I cannot determine what that value is going to be. Indeterminate. Okay, then we say, okay, let's look at a different scenario, a simple scenario now. Let's say we have a limit. This is so simple. The limit as x tends to 0 of the sine of x. All we do is substitute that value into the function, and that value is 0, so this is the sine of 0, and we know that determinant is 0. So the limit as x tends to 0 of sine of what? Of sine of x is what x becomes. Sorry, what sine of x becomes when x becomes 0. All right, that's straightforward. Another example which will hopefully clear this matter. Let's say this was a cos of x. All we do is substitute the cos of the limit value. So this is cos of 0, which is 1. So it means our graph, if x is limited by 0, then our graph is limited by 1. It will, if x cannot get to 0, then our graph cannot get to 1. I don't know if that is complex. Another example would be, let's say the limit of, as x tends to say 2 maybe, of something like 6x plus 2. What is the limit there? Simple substitute the n value, 2 in this case, into the function. So this will be 6 times 2 plus 2. And that will be our whopping 14. Very easy, very straightforward. I don't think anyone has a problem with this. Now, what I'm going to do, I'm going to look at another indeterminate situation, because in our next part of the work, we are going to introduce L'Hopital to see how we deal with these indeterminate values. So I'm going to look at a value like, let's suppose I have a limit as x tends to infinity of x squared plus 2x minus 2x, whatever, plus 2x minus 2 over x squared minus 2x plus 1. And then this here becomes, all we do is substitute that value, the limit value, into the function, and you've got infinity squared, if you care, infinity squared minus 2 times infinity minus 2. That is infinite. But the bottom part is infinity squared minus 2 times infinity plus 1. And that's another infinite. So what you have, you've got infinite over infinite. How do you determine that? It's indeterminate. I cannot say for sure what that is going to give me. So what do I do here? We are going to introduce, to solve this specific case, we get instances where we get our limit giving us infinite plus infinite. Well, that's simple. That's infinite. We had infinite minus infinite. It gave us, oh, that was supposed to be plus. That was supposed to be plus. We had infinite plus infinite. It gave us infinite. With infinite minus infinite, it still gave us infinite. So we cannot really, we can have infinite plus infinite or infinite minus infinite. And this is also indeterminate. These are indeterminate values. Really, we say infinite, but these are really indeterminate values. What we do, we try and see if we can change these forms into either that form or the other form, or maybe it gives us a different solution which is not neither that or that. But if it does give us either one of these two forms, we apply what we call L'Hopital's rule. And on my next part of the work, I'm going to be looking at how you then work out such indeterminate forms into determinate values where it's possible using L'Hopital's rule. That's our last line of work. Hope you enjoyed the intro. This is basically the intro into our limits. So see you next time when you're looking at L'Hopital's rule. Hope you enjoyed it. I did. Come back as a vote of what? Of confidence in us, and we'll give you a vote of thanks. Thank you. Enjoy yourself. See you next time.